When dealing with mixed numbers and improper fractions, it's important to know which one is which. So a mixed number would be when we have a whole number, like 2, attached to a fraction, like 1/3. An improper fraction, on the other hand, would be something that looks like this, where we have a single fraction, where the number on top is often greater than the number at the bottom. So this particular problem tells us that each circle counts as a whole, and they want us to write both a mixed number and an improper fraction that represents this entire figure. For part A, for our mixed numbers, we're going to look at how many complete circles we have, because that's how many whole numbers we actually have. In this case, we have 1, 2, 3 entire circles that are completely full. So our mixed number is going to start with a whole number of 3. Then we're going to look at the remaining circle, which in this case, the circle is split up into 2 sections, and we have one of those sections shaded. So our fraction is going to be 1 out of those 2 sections. This is my mixed number for this entire figure. We have 3 entire circles, and then we have 1 out of 2 of this circle filled in. For our improper fraction, we're going to look at how these circles are divided, in the sense that if I look at just one of these circles, it's split up into 2 pieces, where we have 2 slices of the circle. I want to focus on those half slices, in the sense that here I have 1/2. Here I have a second half, a third half, a fourth half, a fifth half, a sixth half, and a seventh half. I have 7 of those 1/2 sections. In other words, I have 7 halves, or 7/2. And that would be my improper fraction. So again, this number at the bottom came from the fact that each circle was split up into 2 sections. So we have a 2 in the denominator. In total, when I count up these half sections, I have 7 of them. So our improper fraction is 7/2. For this problem, keep in mind that mixed numbers has a whole number and a fraction attached to it. So how many entire circles are filled in? Well, that would just be 1. So our mixed number is going to start with 1 whole. Now if we look at the remaining pieces, we'll notice that this circle is split up into 1, 2, 3, 4, 5 entire sections. So we're going to have a 5 in the denominator. Out of those 5 sections, or those 5 slices, we have 4 of these pieces filled in. So my final answer for my mixed number would be 1 4/5. For my improper fraction, I simply want to count the number of slices that I have in the entire figure. So if I look at how these circles are split up, each one of them has 1, 2, 3, 4, 5 sections in them. So we're going to have a 5 in the denominator of this fraction. Now it's just a matter of counting up those slices. And we're including all of the circles in the figure. So we would count 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, we have 9 slices when we divided each circle into 5 pieces each. So our improper fraction is 9/5. Similar to the other problems, for our mixed number, we want to count the total number of filled in circles. So how many whole circles do we have? We have 2 entire circles. Then we have this remaining circle. It's split up into 4 pieces, and one of those pieces is shaded in. So we have 1 out of 4 pieces that are shaded in, and that's my mixed number. For my improper fraction, we first want to look at how these circles are split up. If we look at this first circle, it's split up into 4 pieces. So our denominator for our improper fraction is going to be a 4. Now it's just a matter of counting how many of those pieces there are within this entire figure. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have 9 of those slices shaded in throughout the entire image. So our improper fraction is 9/4.